Okay, for our topic for today, continuation lang naman to nung last meeting, limits and continuity. So part 3 na po siya. Okay, for this topic, ang magiging discussion or ang focus natin is yung infinite limits. Okay, ang objective for this topic first is to understand and deal with infinite limits in finding the limit of a give function and then find one-sided limit. So before kasi meron naman na tayong na-discuss dun sa week 6 about din dito sa one-sided limits, parang continuation na rin naman siya. And then yung last natin na objective is to use the theories and principles of continuity limit in finding the limit of a given function. Okay, so ano ba muna yung infinity sa limit? So ito daw yung as a function may increase without boundary as gets closer and closer to a from the right. So ito yung tinutukoy natin na letter A. So ito yung asymptote natin. Later, i-recall natin kung ano yung asymptote. And then, itong part na to, as discussed before, siya yung left-hand side or x approaching dun sa negative natin. And then itong part na to, yung sa right-hand side natin, ito naman yung x approaching ng positive side natin. Okay, so as I recall, yung asymptote is a line that a curve approaches as it heads towards infinity. So for example, meron tayo ditong given na meron tayong x, meron tayong y, and yung nagawa natin na based dun sa value ng x and y natin or function natin is nakagawa tayo ng curve. So itong line na to, yung line that approaches dun sa curve natin or heads dun sa towards ng infinity, yun yung tinatawag na asymptote. So merong itong asymptote na to is may iba't iba siyang class depende sa ating nagawang nagawa natin na infinity or yung curve din natin. Ayan, so meron tayo dito mga types. So meron tayong horizontal, vertical, at saka oblique natin. Kung mapapansin nyo, yung first natin, yung curve natin is papunta dito. Ayan, from yung curve natin is possible to going sa right side natin. And meron tayong, habang lumalapit siya, papunta siya ng positive area. So ito is yung line natin is yung horizontal asymptote natin. And then yung next natin is meron naman tayong vertical asymptote and meron tayong oblique asymptote. So yan, yung mga examples natin. Yung horizontal asymptote, so yan. So it is a horizontal asymptote when as x goes to infinity or yung negative infinity natin, the curve approaches some constant value of b. So ito yung tinutukoy niya, yung line na to, yung horizontal asymptotes. And then for the vertical asymptotes naman, as x approaches some constant value c, from left or right, then the curve goes towards infinity or negative infinity. So ito naman yung tinutukoy dito na asymptote o yung letter C natin. Well, for the oblique naman, as x goes to infinity or the negative infinity, then the curve goes towards the line. So y equals mx plus b. So kung dito naman is i-recall nyo yung other maths nyo. So meron tayo dito na yung m is yung sa discussion natin ng slope, and then x, and then yung b natin is yung function of y. For the infinity as a limit naman, so yun nga, yung halos same lang din dun sa discussion natin. We have yung right-hand side and meron tayong left-hand side. But for the infinity, the right-hand limit does not exist, but the behavior is described by writing ito. So we have the limit function of x where x is approaching a positive is infinite, and then if the values of f of x decrease without bound, then we will going to write limit function of x approaching the a positive, which is the negative infinity. So the notation for the left-hand side, left-handed limits. Okay, for the infinity as a limit, let's say ang graph natin is we have the limit, which is we have the limit of function of x or f of x where x is approaching a negative. Sabi natin for the negative is for the left hand, while for the positive is the right. Kung mapapansin nyo, meron tayo ditong letter E, itong part na to, itong vertical line natin sa gitna ng first natin na picture. Ang tinutukoy dito is itong line na to. Kung mapapansin nyo dito, habang lumalapit siya din sa A, so approaching siya ng positive natin. Pero hindi siya dumidikit sa letter E, kaya infinite yung graph natin. Yan. So if ito yung makikita natin, if we have the limit f of x where x is approaching a negative, ang value niya daw is infinite. While for the limit of f of x where x is approaching a positive, ito naman siya, from right, itong line na to. So we have pa din ng value ng infinite. Therefore, kapag meron tayong same value for the limit na approaching ng negative and limit where yung x natin is approaching positive, since pareho siya na infinity or pareho ng value, ang limit natin ng x approaching a is f of x is infinite. Pero kung yung value natin, kung mapapansin nyo dito sa third picture natin and fourth picture, hindi siya pareho or magkaiba ng value. Yung limit na yon is does not exist. But for this one, para sa first picture natin, since same lang naman yung value niya, so nag-e-exist yung limit natin where yung limit natin, x approaching a of f of x is infinite. So for the next naman natin na picture, we have here naman, kung ito is going through the positive of y, positive ng y siya kasi pataas siya. Dito naman is going down naman siya. So pababa ng y natin. So dito, if we will going to get the limit f of x where x is a negative, ang magiging value natin is negative infinity. Ito siya, itong part na to. And then for the limit of f of x where x approaching a positive, negative infinity pa rin siya. So itong line na to. So pareho naman siya, either left or right natin na side, pareho siyang negative infinity. Therefore, yung limit f of x natin where x approaching a is negative infinity. Okay? And then for the next picture, we have here the limit of f of x where x is approaching a negative, itong first natin, pataas naman siya, going siya ng positive side ng y. While for the limit f of x, where x approaching a positive is pababa naman siya, going negative ng y. Therefore, yung negative natin is infinity, and then for the positive natin is negative infinity. Therefore, since hindi pareho yung value natin for the a negative and a positive, yung limit natin of f of x does not exist. Then for the fourth picture, so the fourth picture, kung kukunin natin yung limit of f of x where yung x natin is approaching a negative, mapapansin natin sa graph, we have here yung going down pa rin siya ng y natin. So, papunta siya ng negative y. Where yung value natin dito is negative infinity. While for the limit of f of x, where x is approaching a positive, itong line na to, going up naman siya or going sa positive ng y. Therefore, since hindi pareho yung mismong value natin ng a negative and a positive, yung limit natin ng x approaching a of f of x does not exist. Okay, for this graph, we have the finding one-sided limits. Ang example natin dito is we have the find the limit of f of x where x is approaching to positive and the limit of f of x approaching or x is approaching to negative, where yung f of x natin is equal to 1 over x negative, x minus 2, I mean. Since yung sinasabi natin dito is yung limit of positive, ito siya, itong line na to. And for the limit where x is to negative, ito siya. Since ang positive natin is yung right hand and yung negative natin is yung left hand. Let's say, meron tayo ditong f of x and ang f of x natin, value daw natin, para makuha natin yung f of x is 1 over x minus 2. So, pwede natin makuha itong graph na to, itong mga pinakita natin na graph, kung magsasample tayo ng value. Let's say, ang x natin, kung kukuha kayo ng calculator nyo and papalitan natin yung value nitong x natin doon sa f of x equals 1 over x minus 2. So, makukuha natin itong value natin based sa table. Kapag daw ang ginamit natin na value is 2.1, ang magiging value natin ng y is 10. Let's say dito tayo sa graph natin na to. So, we have here, kunwari, ito yung value ng 2 natin. Yung 2.1 natin is nasa y ng 10. If we will going to use yung 2.01, ang magiging value ng y natin is 100. While for the 2.001, ang magiging value natin is 1,000. Kung mapapansin nyo, dun sa mga values natin ng paggamit ng 2.01, 2.01, 2.1, 2.01, 2.001, habang lumalapit siya dun sa value ng 2 is mas tumataas yung value ng y or lahat siya is going positive ng y. While for this one, let's say ang kukunin naman natin is yung left hand. So left hand, so less than ng 2. Let's say ang value natin is we have the 1.9. Kapag ginamit natin yung formula natin ng f of x equals 1 over x minus 2, papalitan lang natin ng 1.9, ang magiging value ng y is negative 10. Then, if we will going to use yung 1.99, ang makukuha natin value daw is negative 100. And then, kapag pinalitan natin yung x natin as 1.999, ang magiging value natin is negative 1,000. So, ito siya. Habang lumalapit siya sa value ng 2, mas lumiliit yung value natin ng y. And approaching siya sa negative. Therefore, yung value natin ng limit f of x where x is approaching 2 positive and limit of f of x approaching 2 negative is does not exist siya. Bakit? Kasi kung mapapansin nyo, yung graph natin for the positive or the right hand is infinite. So, positive infinity siya. While for the 2 negative, ang value ng f of x natin is negative infinity. And ang rule natin, para masabi na natin na nag-e-exist yung limit na yon is dapat yung positive natin and yung negative natin is same siya ng value. Since hindi same yung limit natin ng positive at yung negative natin, yung limit natin dito is does not exist. Okay, for these limits as x approaching positive infinity, a function may approach an asymptotic value as x moves in the positive or negative direction. Let's say naman dito ang value natin, ang f of x natin is ito. So, sabi natin, ang ginagamit na f of x dito is we have the f of x equals 4x raised to 3 minus 3x raised to 2 plus 5 over the 2x raised to 3 plus 6x minus 1, where yung x natin is greater than 0. So, pwede tayo ditong gumamit ng value. So, papalitan natin yung value ng x natin ng pwedeng higher than 0. So, pwede tayo maglagay ng 0.01 and so on. Kapag ganun daw yung ginamit natin, ito yung magiging graph natin. So, we have the limit of f of x. So, habang nagsasample tayo ng mga values ng x, ang pinakamalapit na value niya is nag-a-approach siya to 2. So, yung limit of f of x where x is approaching infinity is 2. Okay? For our next graph naman, here, ang sample naman natin is we have the g of x equals 1 plus e raised to x. For this value naman, hindi naman siya nagbigay ng category na dapat yung x natin is greater than 0, unlike dun sa first natin na picture. So dito, pwede tayo mag-sample either kahit anong number natin. Let's say meron tayo dito na yung x natin na value is 0. So pwede rin naman siya until makagawa tayo ng graph. And then kung mapapansin nyo, yung mismong graph natin dito is approaching siya sa 1. So habang lumalapit yung value, mas lumalapit siya sa 1. So yung limit of g of x where x is approaching infinity is equal to 1. Okay, for the notation, the formula for this is we have the limit of f of x where x is approaching infinity is equal to capital L. So the limit of f of x as x approaches infinity is L. So the value of f of x get closer and closer to L as x gets larger and larger. Okay, let's say we have here yung one example. Find the limit of f of x where x is approaching infinity and limit of f of x where x is approaching negative infinity where f of x natin is equal to 5 plus 10 over 1 plus e raised to negative 0.25x. So for the solution, let's say we have the x infinity, the values of e raised to negative 0.25x get arbitrarily closer to x. So we have here the limit of f of x where x is approaching infinity is equal to 5 plus 10 over 1 plus 0. So ito is later, papakita natin kung bakit siya naging 15 yung value na to. And then for the next natin, where x is approaching negative infinity, the values of e raised to negative 0.25 get arbitrarily large. So the limit of f of x where x is approaching negative infinity is equal to 5. So ito yung example natin. Let's say ito yung figure natin kanina. Itong part na to. So we have the graph for the 5 plus 10 over the 1 plus e raised to negative 0.25x. Ang sinample dito na values is we have the 0, 10, 20, 30, 40, 50, and 60. So itong mga values na to, ito yung ginamit para dun sa x natin. So pinalitan lang natin lahat. Kapag daw ginamit natin yung 0, ang magiging value ng y natin is 10, which is pinapakita dito sa graph. Let's say itong 0, itong line na to sa gitna, itong part na to, ito yung 0 natin. So kapag daw 0 yung x natin, ang magiging y natin is 10. For example naman, we have the 10, ang magiging value ng y natin is 4.241. Kapag ginamit natin yung 20, we have the 14.933 and so on. Kung mapapansin nyo dito, yung value ng 40, yung value ng 50, and value ng 60 is approaching 15. Ito yung value ng approaching 15. So we have here yung y natin as 4.999. So ito yung value natin na nakuha natin na wherein we have yung value as 15 sa positive infinity. Well, dito naman sa next graph natin, for the next graph natin, same lang din naman siya na yung formula natin where yung f of x natin is 5 plus 10 over the 1 plus e raised to negative 0.25x where yung x natin is negative infinity naman siya. And yung sinample naman natin dito, since negative siya, we have here yung 0, negative 10, negative 20, negative 30, negative 40, negative 50, and negative 60. And then sa graph natin, habang ginagamit natin itong value natin habang lumiliit yung value ng x, mas lumalapit siya sa value ng 5. So, balikan natin yung kanina. For the positive infinity, we have yung 15. And for the negative infinity, we have yung 5. For the limits at infinity of 1 over x raised to n for any positive real number of limit of 1 over x raised to n where x is approaching infinity, ang value daw niya is 0. Then, if we also have the limit of 1 over x raised to n, where x natin is approaching negative infinity, ang value niya pa rin is 0. Natandaan niyo itong formula na to ha. Ayan. So, next natin na example. For the example number 2, ang problem natin is we have the limit of 5x squared minus 7x plus 1 over 2x squared plus x plus 5 where the limit of x is approaching infinity. So yung rule natin dito is first is we need to divide the numerator and the denominator by the highest power of x involved x squared. So meron tayo, ito yung problem natin. Since sa problem natin, ang pinakamataas daw or yung highest power natin is x squared. And then sabi dito is we need to divide yung numerator sa denominator. That's why yung value natin we have here, since meron tayong 5x as yung first natin na value, ito is i-divide natin by x squared. Ang magiging value na lang natin is 5. And then next we have yung 7x or yung minus 7x, i-divide natin siya sa x squared. So meron tayong may iwan na isang x. So we have here the negative 7 over x. Then for the last, we have the 1. So i-divide natin siya by x squared. We have the 1 over x squared. For the denominator naman, i-divide din natin siya with the highest power. So 2x squared over the x squared, we have 2. And then x over the x squared, we have the 1 over x plus 5 over the x squared, we have the 5 over x squared. And then, after natin siyang i-divide, so ito na yung nakuha natin na solution. So we have here the 5 minus 7 over x plus 1 over x squared over the 2 plus 1 over x plus 5 over the x squared. Ayan. Kung kukunin naman natin yung limit natin, so yung lahat kanina, sinasabi naman natin is the limit of x approaching infinity is if we have the 1 over x raised to n is 0. So dito, lahat kukunin natin yung limit ng bawat isa. For the limit of 5, since ang rule natin dito is same value, so copy lang natin siya. We have here the 5. And then for this value, we have the 7 multiplied by the limit of 1 over x, where x is approaching infinity. Ang value nito is 0. Same din dito sa limit natin where we have the 1 over x squared where x is approaching infinity. So 0 din siya. And then for the limit of 2 where x is approaching infinity is same pa rin siya as 2. Then for the limit of 1 over x where x is approaching infinity is same as 0 and same lang din dito. Therefore, ang value natin for this problem, we have 5 over 2. Yun yung final answer natin for this problem. For the example number 3, we have the evaluate each of the following limits. So, nakakategorize naman siya dito. Ang mga hanapin daw natin is we have the limit of e raised to x where x is approaching infinity, limit of e raised to x where x is approaching negative infinity, limit of e raised to negative x where x is approaching infinity, and limit of e raised to negative x where x is approaching negative infinity. For the first problem, we have here, kapag daw meron tayong limit where e is raised to x, we have the infinity. Then for the next problem naman, we have the limit of e raised to x where x is approaching negative infinity, ang value natin is 0. And for the limit where e raised to negative x where x is approaching infinity, we have 0 pa rin. And for the limit of e raised to negative x, where x is approaching negative infinity, the value is infinity. For the next problem, we have the example number 4. I-evaluate daw natin yung limit where e is raised to 2 minus 4x minus 8x squared, where x is approaching infinity. So for the solution, equivalent lang siya sa 0 as based dun sa rule natin. And then for this example number 5, we have to evaluate the limit of e raised to 1 over z, where z is approaching 0 positive. So ang solution dito is we have yung limit where 1 over z, ito is infinite pa rin siya. Therefore, yung limit natin where e raised to 1 over z, where z is approaching 0 positive, is infinity pa rin siya. Itong example number 6 is parang pinapakita lang din dito yung long method. Pero ang magiging solution pa rin natin dito is, yung magiging answer pa rin natin dito is based pa rin dun sa shortcut na pinakita natin na kung ano yung magiging value natin kapag meron tayong negative infinity or positive infinity na based sa exponent natin or exponent rule. For the example 6, we have the evaluate the limit of e raised to 10x minus 4e raised to 6x plus 3e raised to x plus 2e raised to negative 2x minus 9e raised to 15x, where yung x natin is approaching infinity. For this solution, first is by taking the limit of each of the pieces and see what we get. So, gagamitin daw natin siya. Let's say we have the e raised to 10x, we have the infinity. Then if we have the negative 4e raised to 6x, we have the infinity again. Then for the 3e raised to x, we have the infinity. And for the 2e raised to negative 2x, we have 0. And also for the negative 9e raised to negative 15x, we also have 0. And then next step is to divide natin siya. Since 10x is the largest of the three exponents, so if a factor natin siya with the e raised to 10x out of the whole thing. Let's say we have here yung negative 9e raised to negative 15x, i-divide natin siya sa 10 e raised to 10x. So, para mapunta siya sa numerator, magiging negative yung 10x natin. So, we have here negative e raised to negative 15 minus negative 15x minus 10x equals negative 9e raised to negative 25x. For the continuation, doing the factoring on all terms, then we have here the limit where e raised to 10x minus 4e raised to 6x plus e raised to x plus 2e raised to 2x minus 9e raised to 15x, where our x is approaching infinity. And ayan na siya. So we have to take the limit of the two factors. The first is clearly infinity and the second is clearly a finite number. So dito, if factor natin siya with the highest, which is the e raised to negative 10x, ang magiging answer natin is we have the e raised to 10x minus 4e raised to 6x. Yung 6x na to is based lang dito sa 10x multiplied by the negative 4e raised to negative 4x. And then next natin, we have yung 3e raised to x. Ito is based lang sa e raised to 10x multiplied by the 3e raised to negative 9x and so on. So kapag kinuha natin siya, ang value natin is infinity. So same lang din po ito dun sa kaninang discussion natin, yung value ng e if we have yung exponent. To simplify, so we have here the value of infinity times 1 plus 0 minus 0. Therefore, yung value natin is we have the infinity pa rin. For the next problem, so yung next natin is we have the example number 7. So sa example number 7, we have the limit where we have the 6e raised to 4x minus e raised to negative 2x over the 8e raised to 4x minus e raised to 2x plus 3e raised to negative x, where yung x natin is approaching infinity. So for the solution, syempre, first is kagaya lang din nung kanina, na hahanapin natin kung ano yung largest exponent. And then after nun, look at a limit at plus infinity. We only look at the exponent with the positive infinity. Same lang din naman to dun sa kaninang pinakita natin na problem, same with the solution. Then after nun, we have to pa-factor natin siya with the e raised to 4x. So ito na siya. So if we will going to factor this problem, pwede naman natin na i-cancel na yung itong value ng e natin and itong value ng nito. Therefore, we have the limit. We have here the limit where we have 6 minus e raised to negative 6x over the 8 minus the e raised to negative 2x plus 3e raised to negative 5x, where x is approaching infinity. And same lang din siya if we have here the value of e raised to the exponent dito. So equivalent lang din siya sa 0. Therefore, ang value natin is we have the 6 minus 0 over 8 minus 0 plus 0. So isi-simplify lang natin siya. We have the total value of 3 over 4. For the example number 8 naman, so ito yung shortcut lang din siya. Let's say we need to know the value of the limit of ln x, where x is approaching 0 positive, and the limit of ln x where x is approaching infinity. For the first is we have the limit of ln x where x is approaching positive. Yung value niya daw is negative infinity. And then for the limit of ln x, we have the infinity where yung x natin is approaching infinity. Let's say ito yung problem natin. We need to evaluate the limit of ln 7x raised to 3 minus x squared plus 1, where x is approaching infinity. Yung sa solution natin is first is look at what the argument of the log is doing. So ito na yan. So evaluate natin siya. And then next is the argument of the log is going to infinity. And so the log must also be going to infinity in the limit. Therefore, yung value natin ng limit of ln 7x raised to 3 minus x squared plus 1, where x is infinity, is equal to infinity. For this problem naman, we have the limit where we have tangent raised to negative 1x, where x is approaching infinity. Pinakita lang din naman dito yung value natin. So, i-examine lang natin yung graph. Ito yung graph natin. Therefore, yung value niya daw, kapag we have the limit of tangent raised to negative 1x is pi over 2. Or itong range na to we have here, pi over 2. So, approaching din siya dun. Then we have here yung problem natin for the example number 12, where the limit of tangent raised to negative 1 multiplied by x raised to 3 minus 5x plus 6, where yung x natin is approaching infinity. So for the solution daw, we have to use the previous section we have. So yung una natin, and then the limit for this is the limit of tangent raised to negative 1 multiplied by the x raised to 3 minus 5x plus 6, where x is approaching infinity, is equal to pi over 2. For the continuity. For the continuity, so ito daw is a function is said to be continuous at x equals a if yung limit natin for the f of x is equal sa f of a where yung x natin is approaching a. So the function is said to be continuous on the interval a, b if it is continuous at each point in the interval. So ito daw yung rule natin for the continuous or the continuity. And then if yung f of x natin is continuous at xa, then ito yung additional rule natin. So we have here the limit of f of x where x is approaching a is equal to f of a. If we have the limit of f of x where yung x natin is approaching a negative, we have the value of still f of a. And then if we have the value of limit of f of x where x is approaching a positive, we still have the value of f of a. Ayan. So dito meron lang tayong pinapakita na graph. A function is continuous at a point if the limit is at the same as the value of the function. This function has discontinuous. So saan daw natin makikita yung discontinuous? So at x is equal to 1. So yung 1 natin, itong value na to. And for the value of x equals to 2, itong part na to. Yan, itong naka dito. And then it is continuous at x0 and x to 4. So from dito until doon, because yung one-sided limit natin match the values of the function. Yung pinapakita lang dito. Then for the discontinuity, so ito lang yung mga examples natin ng discontinuity. So we have here the removable discontinuities kapag nakita kayo ng line na ganito, ito, and ito. And then for the essential naman, essential discontinuities, we have first is yung jump na tinatawag. Kung meron kayong makikita na line na parang broken line siya, parang tumalon, kaya jump siya. And yung dinidiscuss natin kanina, which is yung infinite, yung nasa middle, possible is yung asymptote natin. And we have the negative, approaching negative, and approaching the positive side. And next natin for the essential discontinuities is the oscillating. So kapag meron kayo nakita na gantong line, parang ano siya, medyo hawig sa heartbeat. Okay, for the example number 1 of the discontinuity. So, yung first natin na problem is we need to determine where the function is not continuous. Since ang problem natin is we have the ht equals to 4t plus 10 over the t raised to 2 minus 2t minus 15. So for the solution, we need to determine the denominator where the denominator is 0. So yung denominator natin na tinutukoy dito is yung t squared minus 2t minus 15. Since pwede tayo mag-factor dito sa value na to, we have, kapag nag-factor tayo, we can get the t minus 5 and the t plus 3. So, ang magiging value ng t natin is negative 3 and 5. So, hindi siya continuous. Kaya, the function will not be continuous at this value. Kaya siya tinawag na discontinuity. For the discontinuity, sabi natin, if yung f of x natin is continuous at x equals b, and the limit of g of x where x is approaching a equals b, then yung limit natin for the f of g of x where x is approaching a is equal lang siya sa f multiply din sa limit natin ng g of x where x is approaching a. So ito is rule lang siya, rule for the discontinuity. Let's say ito yung problem natin. So evaluate down natin yung limit natin where e raised to sine x where x is approaching 0. So for the solution, since we know that the exponential are continuous everywhere, so we can use the principle stated earlier. So yung rule natin kanina, pwede natin gamitin dito, where yung limit natin for the e raised to sine x or x is approaching 0 is equal siya sa e raised to 0 lang siya. And ang e raised to 0 kapag gumamit din kayo ng calculator is equivalent to 1. For the intermediate value theorem, so suppose that we have the f of x is continuous on a and b, and let m be any number between f of a and f of b, then there exists a number c such that first is we have here yung value ng A is less than C and C is less than B, or yung value natin ng C is in between siya ng A and B. And then yung next natin for the number 2 is we have the f of C is equal to M. So for the intermediate value of theorem, so if a function is continuous between A and B, then it takes on the every value between f of A and f of B. So sabi natin dito, yung value natin ng C, kung babalikan natin yung rule natin, for the number 1, we have here yung in between siya ng A and B. So dito mapapansin natin na yung value natin ng A is itong part na to. And sa value na to, we have yung C1 and we have the C2 and yung C3. So ang approach natin ng graph natin is ito. Ito siya. So, yung in between is the C. And yung line na to is yung M. So, for the example number 3, ang problem natin or for the example here is show that P of x equals 2x raised to 3 minus 5x squared minus 10x plus 5 has a root somewhere in the interval of -1 and 2. So for the solution, we need to first is whether or not the function will take the value of P of x of 0 somewhere in between ng 1 and 2. So yun yung una natin gagawin. In other words, we want to show that there is a number C such that yung value natin ng C is 1 less than C or less than 2. Ibig sabihin, babalik lang tayo dun sa una natin na in between siya ng -1 and 2. And yung P of C natin is equal sa 0. So show that the function is continuous and yung m natin is 0. So is between by the P of 1 and the P of 2. That is P of -1 and P of -2, or the P of 2 less than 0 less than the P of -1. For the continuation, we have here to compute yung P natin. We have the P of -1 which is equal siya sa 8 and P of -2 is equivalent siya sa -19. Dito lang din siya ginamit yung sa example natin or yung problem natin na to, where yung P of x natin is equal siya sa 2x raised to 3 minus 5x squared minus 10x plus 5. Din lang siya, sinubstitute lang natin siya. If gagamitin natin tong -1 daw, ang maging value natin is 8. If we will going to use yung value ng 2, makakuha tayo ng value ng -19. So we have here 19 equals P of 2 less than 0 and then less than P of -1 which is yung 8 natin. So range natin is from -19 to 8. Therefore, yung M natin is between P of -1 and P of 2. Yeah. Therefore, for the polynomial does not have the root between the -1 and 2. So for the example number 4, if possible, we need to determine the f of x equals the 20 sine x plus 3 multiplied by cosine x squared over 2 following the values of the interval 0 and 5. So yung hahanapin natin, first is does f of x equals sa 10, or next natin for the b is does f of x is equal to negative 10. Okay, for this problem, kailangan natin first is to show that m lies between the f of 0 and f of 5. If it does not, then use the intermediate value theorem to prove that the function will take the given value. And then for the two function evaluation for each, so if we will going to use the value of 0 of the f of x, makakuha tayo ng value ng 2.8224. And if we will going to use the value of 5 for the f5, so we have the 19.7436. Kung paano natin nakuha siya, based lang din dito sa problem natin. Sa example number 4, where we have the f of x equals the 20 sine x plus 3 times the cosine x squared over 2. Then for the problem number 1, letter E, we need to know kung yung f of x natin is 10, and for the next, if yung f of x natin is negative 10. For the letter A daw, yung m natin is 10, we have yung f of 0 natin is 2.8224 less than 10 less than 19.7436. So, yung value natin is in between naman siya, yung 10 na value na to. Therefore, by the intermediate value theorem, there must be a number of 0 less than or equal, and then c less than or equal 5, such that yung f of c natin is equal sa 10. So, pasok naman siya dun sa range. Then next naman natin, ang hinahanap natin is if yung f of x natin is negative 10. So, m is negative 10. However, in this part, m does not live between the f of 0 and f of 5 kasi nga hindi naman siya nandoon sa range natin kanina na pinakita. So, it is possible that yung f of x natin is not equal to negative 10 where we have the 0, 5, but it is also possible that yung f of x natin is negative 10 in 0, 5. So, for this case, it is not possible to determine if f of x is negative 10 in 0, 5 using the intermediate value theorem. Kasi nga, babalikan natin yung kanina, ang range natin is from 2.8224 to 19.7436. So, ito lang din yung sa graph. Pinapakita lang dito yung graph where we have the f of x equals 10 and the graph for the f of x equals negative 10. So, ito yung mga points niya. Yan. For the two basic theorems, we have the boundedness. So, for this, a function f is said to be bounded or unbounded on a set in the sense in which the set of values taken on by f on the set is bounded or unbounded. So dito lang is pinapakita natin yung, for example, we have the sine and cosine function are bounded on the negative infinity and into positive infinity. Let's say we have the negative 1 less than or equal to sine x and less than or equal to 1, or where yung sine x natin is in between the negative 1 and 1, and also for the cosine x, in between siya ng negative 1 to 1. So we have here na yung x natin is from the negative infinity to positive infinity. So both functions are into negative 1 and 1. So, yun lang yung pinapakita natin. Let's say ito yung graph natin. For the example natin, we have here, let g of x is equal to 1 over x squared and we have the 0. So, para makakuha ulit tayo ng graph, itong graph na to, magpapalit tayo ng value ng x natin to determine ano ba yung approach ng graph natin. So for the explanation of graph, it is clear that G is unbounded on 0 to infinity. Ito yung 0 na sinasabi natin, yung x natin, itong part na to, from 0 to infinity. It is unbounded above. So itong part na to. So however, it is bounded on 1 to infinity. So nasan daw yung 1, itong part na to. If mag-start tayo sa 1, papunta ng infinity. So tuloy-tuloy lang siya. And then the function maps of 0 infinity onto the 0 infinity, and the maps from 1 to infinity onto 0 and 1. For the two basic theorems, we have for a function of continuous on a bounded closed interval, the existence of both a maximum value and a minimum value is guaranteed. So the following theorem is fundamental. For the extreme value theorem naman, we have if f is continuous on a bounded closed interval of a, b, then on the interval f takes on both a maximum value of m and minimum value of small m. So ito lang yung pinapakita natin. We have the small m for the minimum value. Ito siya, kung hanggang saan lang yung pinaka-mababang value natin. And for the maximum value, which is yung capital M natin, dito. So nagbe-base tayo sa approach ng graph natin. For the two basic theorems from the intermediate value theorems, we know that the continuous functions map intervals onto intervals. Now that we have the extreme value theorem, we know that the continuous functions map bounded closed intervals of a, b onto the bounded closed intervals of small letter m and capital M. So, if f is constant, then yung value natin ng m is equal sa m, or equivalent siya, same lang ng value. If yung dun sa value natin, let's say, yung f natin nga is constant, dito sa graph, pinapakita dito sa graph. So, yung value natin for the m, which is yung capital letter M natin, and the small letter m is same lang siya. And same with the interval ng m natin for both small letter and capital letter collapses to a point. So, ito lang siya yung pinapakita ng value na to. Okay? If you do not have any questions, so dismiss na tayo. Thank you for your time.